Hi everyone, Quiveen here from the comfort of my kitchen. In today's video we are going to take a look at Parallax, or more so we're going to take a look at the transit of Venus, but we're also going to take a look at the occultation of Venus that's coming up later this year. So we're going to jump forward to the same event that we took a look at in the last video, which is the 19th of September. So this should be it. You should remember from the last video that the moon and Venus, might be off by a day there, that's alright. The moon and Venus had an occultation, or at least there was an occultation as visible from Ireland during the day. So here's the occultation, just to show it again for anyone who didn't catch the last video. You can see Venus there passing behind the moon and then popping out the other side, but this all happening very much during the day for us here in Ireland, so it is going to be difficult to observe. Of course, with things like these, they are occasionally only visible from certain locations on the Earth. This occultation proved a little tricky because when we moved to a location on Earth where the sun would still be below the horizon when this occultation occurred, it unfortunately put Venus and the moon out of alignment. So we can see that here. Even though this is a location where, for the time where this occultation happens, both Venus and the moon are above the horizon, although the sun is underneath, we can see that we're not quite catching an occultation here. And there is a reason for this. It looks like the reason for this is the 6,000 kilometer jump across the planet. Unfortunately, we are in a very different location, which means we're going to see the moon and Venus from a very different angle. We're seeing it from 6,000 kilometers over to the side. So even though it is the right time, Venus and the moon should be above the horizon while the occultation is happening, but the sun isn't. Unfortunately, just because of the jump, those 6,000 kilometers, it doesn't look like we're going to be able to see it. It looks like the only location I've been able to find where the occultation looks like an occultation and is above the horizon is from here in Ireland, but that's only visible when the sun is also already above the horizon. It's presumably true for a few other locations where the sun won't be quite as high if we don't move as far away from Ireland. So we should be able to see here, yep, there's still an occultation happening. But you might notice that Venus is only just barely getting occulted by the moon here. It doesn't look like Venus is passing directly behind the moon, more making sort of a tangent across the bottom of the moon, a chord. If we jump back to the default location and hop back to that occultation, then we should be able to see it does look like Venus is much more passing through the center of the moon. And even then, it doesn't look like it's perfectly passing through the center of the moon. It looks like this would be slightly more lined up from a different location. We're going to keep looking at Venus because Venus doesn't just get occulted by the moon. If things line up properly, Venus will get in front of the sun. We will have a transit of Venus. And the most recent wasn't that long ago. This does unfortunately mean that the next one will be quite far in the future. So we're going back a few years here, and we're also going back to, just a little bit earlier in the year, just really a couple of weeks ago. So the transit of Venus was not visible from Ireland. If we move through time here, we'll see that Venus, well, it's getting blocked out by a tree, of course. Even that doesn't matter. We'll see that Venus doesn't quite pass in front of the sun from our perspective here in Ireland, though we can see that it does happen once the sun is very comfortably under the horizon. So we will have to jump to somewhere else. But before we do, we'll see the transit of Venus, and we can see it happening with Venus very much coming over the top of the sun. Maybe back in 2012, yeah, there is a chance that the very end of the transit was visible from Ireland. The very end of the transit was visible from here in Europe. The very beginning of the transit was visible in North America. The vast majority of the transit was visible across the Pacific. So that's where we're going to go. We're going to head to the Pacific Ocean. just around here. We'll head a little bit closer to the equator as well, and we'll take a look at how the transit appears from here. So here we are at the very end of the transit, and we'll come back, and you can see that Venus looks like it's crossing over much more of the sun from this perspective than it did from Ireland. So we'll pull back out and we'll see how the sky looks, just to see if this really is above the horizon the whole time. Indeed it is. So here we go. This is the very end of the transit, being seen pretty much at midday, and if we come all the way back to the start of the transit, it should be somewhere around sunrise. Yeah, and we're just losing the end of it there. So if we move a little bit over to the west coast of North America here, this is when we should see the transit beginning. So of course it's going to start once the sun gets above the horizon. If we're seeing it beginning here, then that's how it should work. But just to make sure we do catch it, we'll take a look at everything without anything in the way. So it looks like it has already begun here. So we might need to come around to here. There we go. So this is the beginning of the very beginning of the transit of Venus back in 2012, as seen from the coast of North America. So we can see Venus coming in here, making its contact with the edge of the sun. If we take a closer look here, of course this is a simulation, so it won't display it perfectly. It doesn't display it perfectly. There's normally a little bit of smudge. It's very hard to see Venus just when it's after crossing over the disk of the sun. And there's normally a little bit of distortion. It kind of looks like Venus is pulling out of the blackness of space. That's known as the black drop effect, and it makes measuring exactly when the transit starts and exactly when the transit finishes a little tricky. But the reason why this matters is because the time when you see the transit starting from the west coast of North America, when the transit begins, that's going to be a little bit different to the time that you see the transit beginning from the Pacific, the place where you get to see most of the transit from the middle of the Pacific. So if we zoom in here, we might be able to get even closer, even more accurate numbers due to how accurate the simulation simulates these things. We'll zoom in a little bit more. We'll just get it exactly right, or as close to exactly right as we can. So we can kind of see a similar effect happening there, where it almost looks like Venus is attached to the shadow of the blackness of space, but it's not quite perfect. Hopefully that's, yeah, that looks good. So we can see this happening here at 12 minutes past 3 with this correction. So this is the correction to, determine our time zone. And we can see there it's very accurate. It's 7.12, which again, a bit more accurate than time zones normally work. If we change our location now to the middle of the Pacific, we'll come right over here and we'll focus back in on Venus and the sun. There we go. So even though the time is a lot different, it looks a lot different. You can see that the time adjustment is different as well. Stellarium has actually kept the time, the universal time, the time outside of the simulation, or the time being simulated has stayed exactly the same. But with this additional adjustment, it looks like a different time. But what we can see here is that Venus looks like it's in a very different position. It doesn't look like it's just crossed over the disk of the sun. There's quite a bit of a difference here. The amount of the difference can be measured to help triangulate the distance to Venus and the distance to the sun. And the distance to the sun in particular is important. The distance to the sun, when measured like this, when measured using trigonometry, it's known as solar parallax. We usually, we can see, now this is probably due to the atmospheric distortion, but it really looks like there's a lot more bleed happening here as Venus comes onto the disk of the sun. It looks a lot more fluid, kind of like it's peeling off, there's a little bit of a blurriness there. That is closer to what the black drop effect actually is. So again, we'll zoom in as close as we can. We'll get Venus right on the edge We'll leave the seconds tick forward second by second. There we go. So Venus has just made, this is the third contact. So when Venus's outer edge first touches the disk of the sun, that's the first contact. And then when the sort of other side of Venus fully crosses inside of the disk of the sun, that's the second contact. This is the third contact, and when the outer side of Venus passes all the way out the other side, that will be the fourth contact and the end of the transit. So now we know that the transit is just ending there, and we know that we were able to catch the very end of the transit from Europe, essentially the next day. So we're going to hop all the way around to here again, or well, just to make things fair, we'll keep things pretty close to the equator. We'll hop all the way over here to Africa. We'll zoom back in on Venus. There it is. And very distinctly inside the disk of the sun. So by measuring the times of the transit from different locations on Earth, when it starts, when it finishes, you can get a rough idea using maths. You can get a rough idea of the distance from Venus to the Earth and to the Sun. You're essentially making a triangle with 2 points on Earth being the base of the triangle, and then Venus being sort of the tip of the triangle. And then you extend that triangle out. So the angle at the tip of the triangle has to be the same as the angle on the opposite side when two lines are kind of passing through it, forming two triangles essentially. And then using that measurement, you can figure out the distance to the sun. So we can see some pretty big jumps there with the transit of Venus because it's so small, and because it's a smaller thing in front of a bigger thing. It's a lot easier to see how it's moving across the sun, when it's cutting across and when it's leaving. I hope at least that was all. Oh, well, it still looks like it's under the horizon from that position, but I guess maybe we jumped a little bit too far. If we come all the way up again, I'd say Venus will be after moving off the disk of the sun. Indeed, it has. But that's because we kept the time the same and ignored the fact that the ground would be in the way. Regardless, that's just a little bit on parallax to hopefully explain why the occultation of the moon in the last video was so difficult to see, and to revisit this recent transit of Venus, which was a pretty historical event. We may take a look at some other further in the past transits of Venus and talk a little bit more about parallax and stellar parallax, which is a similar thing, two different locations, but when we're looking at the stars. So you can tune in for that in a future video. If you enjoyed this video, please do like it. If you enjoy this kind of content, please do subscribe to this YouTube channel. You can also read some of this information on my website, queevinscontent.ie. Most importantly, thank you for watching, and hopefully I'll see you back here next time.